When you scroll through Netflix to find a movie, or when NASA processes raw telemetry into a photograph of a black hole, there's an invisible logic layer driving those decisions. That logic is written in Python, and despite the glowing snake logos often associated with it, the language has nothing to do with reptiles. In the winter of 1989, programmer Guido van Rossum was looking for a holiday hobby project. He wanted a name that was short, slightly mysterious, and paid tribute to his favorite British comedy troupe, Monty Python's Flying Circus. He developed the first version on hardware much like this, working within the strict memory and processing constraints of the early 1990s. A moment of wonder. What began as a personal project named after a surreal sketch show eventually grew into the primary infrastructure of the modern tech world. For decades, computer science was defined by high barriers to entry. To communicate with a machine, humans had to learn rigid, counterintuitive syntax. In legacy languages like Java or C++, printing "Hello World" requires 5 lines of code, brackets, and mandatory semicolons. Python prioritized a different rule: readability counts. That same command executes with a single line of plain English. By removing these complex structural hurdles, the language allowed developers to spend less time managing the rules of the code and more time solving the logic of the problem. Because it is easy to read and write, individuals can use Python to automate daily tasks, such as scraping pricing data from a website or sending 1,000 personalized emails in a matter of seconds. But while personal automation is certainly useful, the real challenge is whether this level of simplicity can support the high-stakes demands of global digital infrastructure. When Instagram launched, a team of just 3 engineers used a Python-based framework called Django to build and manage their entire initial backend. This approach proved that small, agile teams could scale an application to millions of users without needing massive engineering departments to manage complex server logic. You see this utility at the edge of human discovery. When the James Webb Space Telescope captures raw light from the Carina Nebula, astronomers use Python scripts to process that telemetry into clear visual data. It operates reliably within high-stakes mission control environments where the accuracy of data processing is a requirement for mission success. Back on Earth, the current boom in artificial intelligence, including the training of large language models like ChatGPT and the systems behind autonomous driving, relies on Python libraries to function. From deep space exploration to the development of machine intelligence, the language has become a standard interface for the fields pushing technical boundaries. Despite its utility, a technical debate persists. Because Python is an interpreted language, it is slower at runtime than raw C++ or Rust. To bypass this limitation, the language utilizes a massive ecosystem of over 500,000 pre-written packages. Think of Python as a steering wheel. When you use heavy data science tools like NumPy, the actual computational math isn't happening in Python. The core engine underneath is written in ultra-fast C code. You provide a simple instruction in the top layer, and the system hands it off to the C language engine to execute the heavy lifting at high speed. Its power is not as a standalone tool, but as a coordinator that allows humans to easily control high-speed computational engines. This ecosystem is sustained by millions of developers. If you encounter a specific coding problem, it is likely that someone has already published an open-source solution for it online. As the technical demands of AI, quantum computing, and data analytics grow, the need for a versatile interface to manage that data remains constant. This makes the language a bridge across the technical divide, serving as an entry point for students while remaining powerful enough for NASA engineering. Whether you are looking to automate a single spreadsheet or architect the systems behind the next phase of AI, learning the language provides a direct path into the tools currently driving the modern economy.